We're going to be having a look at the quotient rule. Now the big thing with the quotient rule is that we are trying to derive functions that look like u divided by v, where u and v are both functions. So you can have an example over here. We've got 4x squared minus 2, which is the top function, over x to the 7 plus 1. The question is, what is the derivative of this function? Now this is a really annoying one. We actually can't derive it in its current form, but we can if we know the quotient rule. And the quotient rule says this: if you have a function which is u and v, which each can be derived, so u can be derived du dx, and v can be derived dv dx, then the whole function dy dx is equal to the derivative of the top, du dx, multiplied by the bottom, subtract the derivative of the bottom, dv dx, multiplied by the top, u, all over v squared. Alrighty, so that is the quotient rule. So it is the derivative of the top times the bottom, take the derivative of the bottom times top, all over the bottom squared. Okay, so in order to work it out, we just need to work out each of these separately. So let's do that over here. And in this case, our u function, our top function, is 4x squared minus 2, and our bottom function, v, is x to the 7 plus 1. The derivative of u with respect to x, du dx, is 8x. That's it. The derivative of v with respect to x, dv dx, is 7x to the 6. Alrighty, so I've done all my working out. Now I can go straight into the formula, which means that the derivative of y is going to be equal to the derivative of u times v minus the derivative of v times u all over v squared. So let's do some substitution. Alrighty, so du dx is 8x times v, and subtract the derivative of v, 7x to the 6, multiplied by the original function u, 4x squared minus 2. And this is all being written over x to the 7, which is v squared. Alrighty, so this is the quotient rule. We've done it. Now we've just got to do is some algebraic cleanup. So first thing, I'm going to expand out these brackets. So I'm going to get 8x to the 8 plus 8x minus, and then I'm going to expand out these brackets. We're going to get 28x to the 8 minus 14x to the 6. And then I can get rid of the negative here. Makes that plus, makes that negative. And now I can do some like terms. I've got two of these terms, both to do with 8x. Oh, sorry. Got to put my denominator in. X to the 7 plus 1 squared. Alrighty. And 8x to the power of 8 minus 28x to the power of 8 is minus 20x to the 8 plus 14x to the 6 plus 8x. We try to put your polynomial in power order, all over x to the 7 plus 1. And there we go. That is an example of quotient rule. However, that's using the du dx notation, the Leibniz notation, let's have a look at it using function notation. So if I have h of x, which is f of x over g of x, the derivative h dash of x is equal to f dash times g minus g dash times f all over g squared. So that is the quotient rule in function notation. So let's work out h dash. So in this case, f of x is going to be equal to 6x to the 3 minus 2, and f dash of x is just going to be equal to 18x squared. G of x is going to be equal to 5x squared minus 2x, and g dash of x is equal to 10x minus 2. Alrighty, so like before, now that we've done that, h dash of x is just going to be substitution. So f dash goes first, then g, then g dash, running out of space here, and then f. Alrighty, so I've now, nearly finished. I always forget to do the bottom. All over the bottom squared, which is going to be, in this case, g squared Alrighty. So like before, we've got to expand our brackets, except we've got a few more brackets to expand this time. So let's start with the top bracket. 18x squared times 5x squared is going to be 90x to the 4. 18 times negative 2, negative 36. X squared times x is x to the 3 minus. Now these brackets are a bit more intense. We've got a few pairs of brackets to expand. So we can get 10 times 6 is 60. X times x to the 3 is x to the 4. 10x times negative 2 is minus 20x. Minus 2 times 6x to the 3 is minus 12x to the 3. And minus 2 times minus 2 is plus 4. But because we've got this negative out the front, I can expand out the brackets and change the signs of everything on the inside. And the denominator, once again, is just going to stay the same. So I'm not going to touch the denominator. 5x squared minus 2x all squared. Alrighty, now it's time to collect some like terms. We have got 2x to the 4s. We have got 2x to the 3s, and nothing else has got like common. So 90x to the 4 minus 60x to the 4 is 30x to the 4. Minus 36x to the 3 plus 12x is minus 24x to the 3. Plus 20x minus 4 all over that denominator from before. 5x squared minus 2x all squared. And that is how you do quotient rule, both in function notation and in Leibniz notation. Alrighty, got any questions? Let me know. Otherwise, see you in the next one.